Yes.
Okay, great. So the first one that we're going to start with, as I said, we're doing patterns, right? So the first one that we're going to start with, ish, okay, we're going to start with the arithmetic, because we know we have different types of patterns, right? We're going to start with the arithmetic sequence. So, whenever you hear arithmetic sequence, this is what I want you to think. I need you to think common difference. They have a common difference, right? You'll just see what I mean by this in a few. Difference. So let's say we have a pattern and it looks like this. It's 9, 11, 13, 15. Okay, this is 15, this is 17, 19, 21. Okay, let's check the difference in between the two terms. Remember, I said for an arithmetic sequence, they have a common difference, right? So when you say 11 minus 9, what does it give you? It gives you what? 11 minus 9. 11, 10, what? 9, 10, 11. So it's a 2. The difference, what's the difference between 11 and a 13? Sorry, it's a 2 again. What's the difference between 13 and 15? It's a 2 again. What's the difference between 15 and a 17? It's a 2. So can you see that for an arithmetic sequence, we have what? A common difference. And this is the general formula for an arithmetic sequence. It is Tn equals to A plus n minus 1 multiplied by d. Okay, and this Tn, okay, let's start with A first, Lena. A, it's the first term of the sequence. So in this case, our A is going to be 9 because 9 is the first one, right? And the n, it's the position of where the number is. So if we look at this 9, it's number 1 in the sequence. So its n would be 1. Now let's look at this 13. Somebody's trying to join. Alright. Right. Okay. And then this n, as I was saying, it's the position of where the number is along the sequence, right? Because if we look at this 13, in terms of the sequence and where it is, we would say it's occupying position what? This is 1, 2. It's occupying position 3, right? And when you look at this 19 along the sequence, which position is it occupying? Remember? And it's just position. This 19, sorry, this 19, it's number 1, 2, 3, 4, 5, 6. So, so the thing in the sixth position, it's number 19, right? Okay, then this D, it's just our common difference, right? And now let's look at this TN. Remember we said that the N, what is it? It's the position, right? So if you say, go to position number 2, you'd say 1, 2. And you know you're going to find what? 11. This TN, it's the value of that position. So if we're saying go to position number 2, you go to 1, 2. You'd stay here, right? And then when we ask you, what is the value of position number 2? You then say 11. This 11, it's the TN. Do we all understand this? Do we all get this? Okay. Now let's do an example. Ne? Let's say we have. Okay. Let's say we have 10, 7, 4, and what? Okay, fine. When we try and compute the difference, remember we're going to say what? T2 minus T1, get what it is? T3 minus T2. Okay, wait. Okay, guys, wait a minute. Somebody's knocking on my door. I'll be back. Sorry about that, huh? Sorry. But I'm back. Okay, so we had a 10, a 7, a 4, and a 1. All right. This is what we're working with. Wait. And it extends all the way to a negative 302. So these are our terms, right? In this sequence right here. Okay. And number one, they're saying, I'm just going to like write down the questions. Determine this DTM, it just stands for determine. Determine the value of n equals 221, right? And for the second one, they're saying how many terms are in this? How many terms are in this sequence? Okay, fine. Now, they're saying we have a 10, 7, 4, 1, all the way going to what? This is the last term in our sequence, by the way, negative 302. So now they're telling us that we should determine the value of what? N equals to 21. So they're trying to tell us that figure out that what will be the value if our position is what is 21, right? And remember, this is an arithmetic sequence. First things first, it has to have a common difference, right? Now, when you move from these two, what is the common difference? Like if you say 10, how did you get to 7? You must have subtracted 3 from this 10, right? Okay, let me rewrite it here so that we work neatly. 4, 1, negative 302. Sharp. So they're telling us that the first one, it's 10. So I'm saying, how did you get to 7? you must have subtracted by 3. And then if we have a 7 and a 4, how did you get to the 4? You must have subtracted by 3, which now shows that we have what? A common difference of minus 3, right? Okay, so which means, wait, remember for an arithmetic, our general formula has to take the form a plus n minus 1 or multiplied by d. What is our a in this case? It's this one, right? So our a will be 10. What is our n? Wait, before even our n, what is our d? We know that the d is what? It's minus 3, right? So they're telling us that what is the value of position 21? If n is equals to 21, what is the value? So they already gave us n for what? For 21. So all that we have to do now in order to find our tn is substitute all these values into this part over here. Do we all get what's happening over here?
Yes.
Yes.
Okay, so then it would go this way. We're going to say tn equals to, what is our a? 10, right? Because it's the first um value in our sequence, plus what is our n? It's 21, because they said determine the value of n equals to 21. So they already gave us the position. So the position would be 21 minus 1 multiplied by, what is our common difference? Minus 3. So in order to figure out what position 21 would be, you're just going to say tn equals to. Brr, where's my calculator? Ish. Guys, can somebody just punch this into the calculator? I can see it. Okay. Just say 9. No, this is 10. Why do I have a 9 here? It has to be 10 because it's our A. Yeah, I had written A over here. Our A is 10 because 10 is the first one. Can somebody put this into the calculator? Oh,
Negative
actually,
50.
it's what? Negative?
50.
Negative 50. I mean, which makes sense because as you can see, if we keep on subtracting by 3, subtracting by 3, subtracting by 3, I mean, it's not too far fetched to say that if we keep on subtracting by 3, we are some way, somehow going to end up into our negatives. So the value of n equals to, what is it? 21 is negative 50. Right. Okay. Now they're asking us how many terms are in this sequence, which is number 2. How many terms are in this sequence? Remember, this negative 302, it's the last term of the sequence that we have over here, right? So if this negative 302 is the last term that we have, we can just find out which position this negative 302 holds. Then since, well, we know that it's the last one in the sequence, we can then conclude that we have that much terms in the sequence. You guys get it? I mean, if we have A, B, C, D, E, and E, it's the last thing that we have in the sequence, right? We can conclude that we have 1, 2, 3, 4, 5 terms in this sequence because we know that E is the last one and it's number 5. So overall, we have 5 terms, right? So we can just find out the N, which is the position of this negative 302. So let's do that, right? So we have Tn equals to A plus, sorry, N minus 1 multiplied by D. What is our Tn? We already have the value. We're just calculating for this N. It is negative 302 equals to, what is our A? 10 plus, what is our N? Our N is what we're looking for. Remember that? Minus 1 multiplied by, what is our common difference? Minus 3, right? So we're going to have, okay, let's work it out. Horrible. Negative 302 equals to 10. Then over here, we can like just, what do you call it? Multiply into the brackets, right? In order to get rid of these brackets. So we're going to say negative 3 multiplied by n, which is going to give us minus 3n, and we're going to say negative 3 multiplied by negative 1, which is just going to give us plus 1. Hey, plus 3. Sorry. And when you say minus 302 equals to this 10, when you add it with this, because we're adding like terms together, right? 10 plus 3 will just give you 13 minus 3n, right? And you have to transpose this 13 to the other side. So we'll now have negative 302 minus 1, 3 equals to negative 3n. So onto your calculator, if you say minus 302 minus 13, what is it giving you?
Negative 315.
Negative 315 equals to negative 3n. So you have to divide both sides by negative 3. Can you do that for me? So that we can have our n equals to what? These two are going to cancel one another. Say 315 divided by 3.
Mm-hmm. 105.
105. So which means the nth, like the position of this negative 302, is what? N equals to 105. So if we were to move along the sequence and go to position 105, we're going to find this negative 302. So it means that we have 105 terms in this sequence over here. Do you guys get this?
Yes.
Okay,
Yes.
great. Mm, okay, and then yeah. So let's say we have um 2x, x plus 1, 6 minus x, right? And then again, this is an arithmetic sequence. What do we know? The difference between the two. So if we go x plus 1 minus 2x, the difference, we'll get a difference, right? It has to be equals to what? It has to be equals to 6 minus x minus x plus 1. What I just did over here, right? I just said if we have T1, T2, T3, T3 minus T2, it should what? Be equals to T2 minus um T T2 minus, what do you call it? T1, right? Because it's an arithmetic sequence. So now over here on this is another sequence that we were given. For this one, they said DTM, the value of x, right? So if they're telling us that we should determine the value of x, which is this over here, what we can do, because we say if it's an arithmetic sequence, we know that T3 minus T2 should be equals to T2 minus T1, right? We can equate these two and then find our x. So that's what we're currently going to do. We're going to say 6 minus, because this is T3, this is T2, this is T1. We're going to say 6 minus x, right? Minus T2 x plus 1 equals to T2, which is x plus 1, minus the first one, which is 2x. So we're going to have a 6 minus x minus, when we now multiply in the negative into the bracket, we're going to have minus x minus 1 equals to x plus 1 minus 2x, right? Now from here, all we just have to do is just solve for x. Right. So we have 6. Let's just group all our like terms in it. We have 6 minus 1, which is going to give us 5 minus these two together. It is going to be minus 2x, right? Equals to, you guys agree with me, Musna? Like you guys get it, everything was that.
Yeah.
Okay. Then here, over on the side, if we group the like terms, we have x minus 2x, which is going to give us minus x plus 1, because this is just 1 minus 2, which is negative 1. Right. So now we have to transpose and have our respective like terms on like their own individual sides. Right. So we're going to have on this side, sorry, we're going to have 5 transpose the 1 minus 1 equals 2 minus x plus 2x. Right. Now we're going to say 5 minus 1, it's going to give us 4. Minus 1 plus 2, is it positive 1? It's positive 1 there. Minus 1 plus 2 is positive 1. I think so. X. So therefore, our x equals to 4. You see? So now you just solved for your x. So now you can just take this x, substitute it over here so that you can now know what your T1, T2, T3 are. Right? So you're going to have 2 into 4, then 4 plus 1, 6 minus 4. Right? So now we have 8. 4 plus 1, 5, ne? 6 minus 4, 2. So now let's check. 5, 6, 7, 8. So minus 3 going that way. So 5, difference between the two, minus 3. So indeed, it is an arithmetic sequence because it has a common difference, right? So fine. Now we have another question. Just do this. Okay. So they're telling us that the third, okay, just write it. The third term of an arithmetic sequence of an arithmetic sequence. The third term of an arithmetic sequence is 1, 4. And the 10th and the 10th is 84. Okay. Okay. So they're telling us that the third term of the arithmetic sequence is what? Is 14. So we know that when n equals to 3, Tn equals to 1, 4, right? And the 10th is 84. So we know that when n equals to 10, Tn equals to 84. So from this question, then they ask us to calculate the 100th term of the sequence, right? Let me just write it here. Calculate the 100th term. So again, they're saying the third term is what? 14. 10th term, it's 84. So from all this information that they've just given us, they're telling us that calculate the 100th term. So, okay, fine. This is what it's going to look like. This is basically now solving arithmetic sequence using, am I lying? I don't think I'm lying. Okay, let's just do it before I start now giving names to stuff that don't have names. Fine. The third term, it's this and this. Okay, fine. We have Tn equals to A plus bracket n minus 1 d, right? They're telling us that the 14th term equals to, we don't know what our A is, right? So we're going to say A plus, but when 14, when 3, what? We have position 3 being a 14th term, right? So we know that n, it's 3 minus 1 multiplied by d. So we're going to have 14 equals to a plus in bracket 2 multiplied by d. So this is the first equation, ne? Then for the second one, we're going to have Tn equals to a plus bracket n minus 1 multiplied by d, whereby what is our a? Our a is, no, we don't know what a is currently. But what is Tn for the second one? Tn, it's 84 a plus, what is n? 10 minus 1 d, right? So we have 84 equals to a plus 9d. So when you look at it like this, right, you can tell that now from both equations, we have two unknowns, which is what? A and D. These are our unknowns. So they're telling us that from whatever it is that we've given you, we want you to calculate the 100th term. But we cannot calculate what the 100th term would be if we don't know what our A and what our D is, right? So from just this, we can use simultaneous equations. Né? You're going to see how we're going to do that. Use simultaneous equations to solve for our A and our D, and then we'll be able to compute this question over here. So let's do that now. Really now. Ah, So, okay. 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 Here am I. So we have for the first one, we have 14 equals to A plus 2D, right? Which is our one. And then for the second one, we have 84 equals to A plus 9D, right? So this is your second equation. What you can just do, either from these two, make A or D the subject of the formula, then substitute it into another formula, and then get what it would be. Let's do it over here. So because we're trying to make A now the subject of the formula, we're going to say 14 minus 2D equals to A, right? This would then be your third equation. So now you're going to take your third equation, substitute it into your second equation, right? So wherever you see A in the second equation, you write 14 minus 2D. So you're going to have 84 equals to, now we have A, which is just going to be 14 minus 2D plus 9D. So we have 84 equals to 14 um then when we add 9D, okay, let me just say 9 is 2D plus 9D. Then we have 84 equals to 14. When we add 9 minus 2D to 9D, we're going to have plus 7D, right? And then we transpose this 14 to the other side. So we're going to have 84 minus 1, 4 equals to 7D. Can you put this 84 minus 14 into the calculator for me? Is it 70?
Yes. It's 70.
So we're going to have 70 equals to 7D. Now, because we're trying to find out what D is, we can just divide both sides by 7. Please do this for me as well. Check what your D is. You're going to have D equals to
It's 10.
10. Okay, fine. So now you have your D. You're one step closer, right? So, but because you have your D, remember we have Tn equals to A plus n minus 1 multiplied by D. We just got the D, but we don't know what the A is, right? So in order to figure out what the A is, we can just take this D, substitute it here, right? So we're going to have 14 minus 2 all into 10, because our D is 10, right? Equals to A. So we have 14 minus 20 equals to A. 14 minus 20, is it going to give you negative 6?
Yes, it's negative 6.
Okay, minus 6 equals to A. So see now you have your Tn equals to, what is your A? Minus 6 plus n minus 1 D. Now remember from this question they had said what? Calculate the 100th term. So basically tell us what position 100, what its term would be, what its value would be. So they just gave us the position, which is just the n. So we can just substitute it over here because we now have all these values, right? So we're going to say Tn equals to minus 6 that we just calculated, plus what is our n? 100 minus 1 multiplied by, what is our d? 10. 10. Okay, 10. So Tn would now just be oh, minus 6 plus 99 multiplied by 10. Can you put this into a calculator for me?
184.
184.
No, it's
900. Oh,
984.
okay. So Tn, the term of the 100th position, would be 984. Do you guys get like this and this, and how we had to now use simultaneous equations to be able to find our A and our D?
Yes.
Okay. So the second one that we're going to touch on, let me just do this. One. Okay. So the second one that we're going to touch on is what? Geometric sequence. Okay, let me just use the other page. Okay, the one that we're going to touch on now, it's called geometric sequence. As I said, this is a very short chapter and it's short, it's very doable. Hence, I said, let's just do it so that when we're doing functions questions, we couple it with patterns questions because the more the merrier. Okay, so now we have geometric sequence. How this one differs from the other one is that instead of a common difference, we have a ratio. But we'll get into that. So remember the other one, its general formula was Tn equals to A plus open bracket n was it n minus 1 multiplied by D. This one, its um general formula, it's Tn equals to A multiplied by R n minus 1. This over here, it's ratio. And this here again, it's still our first term. And this again, it's still the position. So everything still remains the same. The only difference that we have, it's this, and how basically it itself as a whole function, I don't know, as a whole expression looks, right? So now let's say we have oh, variety. Let's say we have 1 comma 2 comma 4 comma 1 2 4 8 comma 1 6 comma 32. Remember what I said, the difference between the other one? Remember the other one, you could just do this and say, okay, this would be like minus 3, and then of course in the other two terms there's going to be like a minus 3 as well. But here it differs because we are supposed to have a common ratio instead of a common difference. So what we mean by that is that T3 divided by T2 should be equals to T2 divided by T1, which would be equal to T4 divided by T3. So when you get the ratio between this one, and this one, when you say 4 divided by 2, It is what? It's 1, right? It's going to ban. Let me just write 1 over here. Sorry. And then this was our what? This was
It's
our,
2.
oh, it's
Yes.
2. Sorry. Yeah, it's 2. It's 2. Right? So 4 divided by 2, it's 2. Right? 2 divided by 1, it's 2. 8 divided by 4, it's 2. So can you see that the ratio between these two is equals to the ratio between these two, which is also equals to the ratio between these two. Same way, if you were to say 16 divided by 8, it is still going to give you 2. So we have a common ratio of 2. Do you get that? So since, well, we have this sequence over here, right? Let's say, let's try and express it in its general formula. We're going to have Tn equals to, what is our first? Okay, let me just say Rn minus 1. Tn will be equals to, what is our first term? 1 multiplied by, what is our common ratio? 2. What then it will be n minus 1. So it's just 2 raised to the power n minus 1. This is the general formula, right, of this sequence over here, right? So let's say they say determine the term 21. Okay. DTM the term, I think I should have just said DTM the 21th term. 21th term. Again, we're given our n. So what we just have to do is look for the value of the 21th term. So we can just say Tn equals to 2 into our bracket. What is our n in this question? It's 21 minus 1. So our Tn will just be, can you put this into the calculator for me? What is it giving you? This would be 2. I get it, this is 21 minus 1. This would be 2 raised to the power 20.
It-
What is it giving you?
It's 1,000,000
2 raised to the power 20.
48,576.
Okay, 1048 576. This, ne?
Yes.
Why is it scaring me? But we did nothing wrong. I mean, this is our T1.
It is scaring me too. Sorry.
But we did nothing wrong. I mean, we got our common ratio. This is our common ratio. This is our n. They're saying determine the 21th term. That's what the question said. They didn't say 21, it's the term, so determine its position. Okay, this is what you would get for the 21th term. Now, let's just do a counter problem where they're maybe telling us 21, it's the term. Okay, do you understand what I mean? Like, this is correct, ne? I just want us to do a counter problem whereby 21, like, let's say 21, it's the value now. Find n, just to see how it would go, ne? So we have Tn being equals to 2 raised to the power n minus 1, right? We said in this case, not this one, in this case, 21 would be the Tn equals to 2 raised to the power n minus 1. So we know that in order to work with this, right? We're going to have to what go back to our laws of exponents. Remember, if you have the same basis, now you can drop the exponents, right? So if you have a 2x minus 1 equals to a x plus 1. See, we have the same basis. So now we can drop the basis and just work with the exponents and just equate 2x minus 1 to x plus 1. So, but now here, 1 is a 2, 1 is a 21. The bases are not the same. So we cannot work with the exponent as of yet, right? So what you can do is, no, this question was like this, guys, because this 21 cannot you cannot you cannot make it have a base of 2 and an exponent of something. So this question was actually supposed to be like this, not like this. Ne? Just that I thought that maybe you could get it like it. Of course, it can always be asked like this, but not with this, like with these terms, because that's what's making us not be able to work around with this one. Because if you're trying to turn this 21 into something that's going to have a base of 2 so that we can drop the exponents in this particular question, it's not going to work. But we are going to have a question whereby we have to apply this, like like this working instead of this. But yeah, even though it's scary and it looks very funny, it is supposed to be like this. Ne? Uh, yeah, I'll just have to, when we do an exercise, I'll just have to find a question where we can use this. But yeah, so far, do you guys get what we're doing here?
Yes.
Yeah.
Okay, great. Another question. This is actually a lengthy question. So they say, let me write what the, somebody's trying to join now. Aaron. Okay, so they say, um, let me rewrite the question. They're saying John ends 4,000 in his month. Okay, let me just write using this. John ends 4,000 in his month. In his month. His earnings, okay, I think this was supposed to be first. His earnings increase by 5% of the previous month, by 5% of the previous month, right? Thereafter, thereafter, determine what John will earn by month 10. DTM. Remember, DTM just stands for determine what John will earn by month 10. Okay, so they're saying John earns 4,000 in his first month, right? So let's say month 1. John, how much is he earning at the first month? 4,000. His earnings increased by 5% of the previous month. So month 1, January, John earned 4,000. Month 2, which is February, to John's salary. So 4,000 is the base, right? To John's salary, they added 5% of 4,000. to his second month salary. So month one, John earned 4,000. Month two, John earned his 4,000 and the 5% of the 4,000, right? So now let's do this. Okay. So when you say 5 on your calculator, if you punch in 5 divided by 1,000, because we're trying to find out what is the 5% of 4,000. Like this increment, it how much was it really, right? So we said 5 divided by 100 multiplied by 4,000, it's going to give you 200. So which means in the second month John got his 4,000 plus the 200. So which means in the second month John got 4,200, right? So now month 3. Remember, they said what? They didn't say like it just keeps on increasing by 200. They said John earns 4,000, sorry, in his first month. His earnings increased by 5% of the previous month. So month 3, it's going to increase by a 5% of this month over here. This month that we have over here, right? So now we have to calculate 5% of this month, right? So again, we're going to say 5 divided by 100 multiplied by 4,200. Now it's giving us 210. So which means now what? John is going to now get R4 1 0. Do you guys get this? Like this part over here.
Yes. Yeah.
Yes.
Okay, great.
Meaning like a 200 every month.
Sorry?
Ke go tlo increase ka 200 every month. Ke 5% ya 4,000 eo.
No. Yeah, that's the problem. But increase like a 5% there, what he got the previous month. Over here, it increased ka 200 between month 1 and month 2. It increased ka 200. Why? Because month 1 in ile 4,000. And what's 5% of 4,000? 200. Then we got
Oh,
this 200. Now we get to month 3. Now you have to calculate, what do you call it? You have to calculate 5%, yeah, 4,200. Yeah, the 5%, yeah, the previous month. But his earnings increased by 5% of the previous month. Do you get it?
yeah, me and I get it.
Okay. So now, nakula re le ko month 3, nakula no batla ba mpatele salary. They had to add 5% of the previous month to what he currently had, and then it gave us 4,410. Because when you say 5% of, okay, when you say 5 divided by 100 times 4,200, you're going to get 210. So this 210, once I added to the 4,000 that he was supposed to get, the 4,200, it gives you 4,410, which is what we have over here. Right. So now remember, this is a geometric sequence question. So which means it'll take the form TR equals to A R n minus 1. So firstly, let's try and calculate what the ratio is. Remember, we said T3 divided by T2 should just be the same as T2 divided by T1. Right. So for T3, we have 4,410 divided by what is our T2? 4,200. Let's see what it gives us. 4,410 divided by 4,200. It's giving me 1,05. Now let's see between T2 and T3, what is it giving us? So it's 4,200 divided by 4,000. It's giving me 1,05. So can you now see that um the ratios in between, they're now equal. They're both eh, okay, they're both equals to 0.15. So which means indeed this is a geometric sequence, right? So we're going to have our R. Okay, so we have now Tn equals to, what is our A? Our A, it's the first payment that he got, 4,000, right? So it's going to be 4,000. What is our R? 1,05. N minus 1. So this is the general formula, right? So now then they proceeded to ask us, what will John earn by month 10? So this is simple now at this point. If they gave us month 10, we know that this is our N. And if they want to know what will John be earning, they just want to know the Tn, right? So we're going to go Tn equals to 4,000. 1,05. What is our N? They said by month 10, right? So it's going to be divided by minus 1, sorry. So therefore, our Tn will be equals to 4,000 all into 1,05, close bracket, all raised to the power. 10 minus 1 will just be 9. So by month 10, John will be earning 6,205,31. Do you guys get this?
Yeah.
Okay, perfect. Okay. Mm, okay. Okay, let's say we have here is okay. Let's say we have x 2x plus 6, 16x, right? And they're telling us DTM x. Determine what x would be, right? So remember, this is a what? Geometric sequence. We know that T3 divided by T2 equals to T2 divided by T1, right? Now, this is our T1, T2, ooh, guys, T3. Fuck, sorry. So if we go T3 divided by, because we're trying to determine this X value over here, right? So if we go T3 divided by T2, we would have 16x all divided by what? What is T2? 2x plus 6 equals to, what is our T2? 2x plus 6 divided by, what is our T1? X. When it's like this, we can easily just cross multiply, right? This way, this way. So we have 16x all into x equals to 2x plus 6 all into 2x plus 6, right? Close bracket. 16x times x, we're going to have 16x cubed equals to 2. What is now happening here? Okay, 2x plus the 6, you just have to multiply it into the bracket, right? 6 times 2x would now be what? It would be 12x. What's 6 times 6? 36 plus 36, nah? This is squared, guys. This is not cubed, sorry. Squared. Right. Now we can see that we have an x squared, which means we have what? A quadratic. So we can now just transpose everything to this side. But let's say 16x squared equals 2. Let's fix this up first. 2 times 12. No, 2 plus 12. It'll just give us 14x plus 36. So we can just transpose this to this side and say we have 16x squared, right? Equals to 14x. Hey, man. Transposed. So it's going to be minus 14x, right? minus 36 equals to 0. Now we can see that everything over here it's a multiple of what? Of 2. So we can divide everything over here by 2. This divide by 2. Just so to make it simpler to work with, right? So when you go 16 divided by 2, you'll have an 8x squared minus 14 divided by 2, 7x. 36 divided by 2 minus 36. What? Minus 18 equals to 0. Now we have this over here. We cannot further. Yo, somebody's waiting. I think Darren is having problems with joining. Darren, are you experiencing any problems joining? I can't hear you if you're saying anything. Mute it. Okay. Can I unmute him from
Oh,
my side? Yeah.
yeah, I joined now.
Uh, but now you're joining and we're like 1 hour into the class. Or were you busy with something?
Yeah, I was busy with something.
Oh, okay. No problem.
So
So
which part of it seems like this is algebra? Which part are we doing?
we're doing patterns.
Okay.
This is just a question that we got. Yeah. So once it gets here, because we have to solve for x, we'll just use what do you call it? This. Sorry, I forgot the name. Minus b plus minus root b squared minus 4ac. Sorry. All divided by 2a in order to be able to find our x, right? So we can say x equals to this is a b c, right? X equals to minus into bracket. What is our b? Minus 7. Minus 7, close bracket, plus minus root. What is our b? Minus 7 minus 7 squared minus 4. What is our a in this question? 8, right? What is our c? Minus 18. All divided by 2, all into what is our a in this question? 8. Right, now let's fix this up. We have x equals to this. When you multiply it in, it's going to give you a positive 7 plus minus root. When you punch this into your calculator, minus 7 squared minus 4, 8 minus 18. It's giving me 625 all divided by 16, right? So we from this we can get two values of x. So x will be equal or x will be. So fine. We just punch it into the calculator. Good. It's giving me, let's say 7. Let's start with the plus first, ne? So we're going to say 7 plus root 625 divided by 16. Eban. No, I made a mistake. 7 plus root 625 divided by 16. Okay, one is giving me a 2. The first x, it's giving me a 2. Can somebody fact check it for me, ne? And then the other one is giving me negative 9 over 8. Are these values what you guys are also getting?
Yes.
Okay, great. So now we can take, firstly, we take 2, substitute it into this, right? So we will have, okay, we will have 2. Now into this one, we'll have 2 all into 2 plus 6, 16 all into 2, right? So we will have 2, because we're trying to suss out if our x will be this one or this one, right? So that we have the correct value of x, right? We're checking. So when we say 2 times 4, 2 times 2, it will be 4 plus 6, it has to give us a 10. right? Then 16 times 2, I think we've been doing it. It's just 32. So to check if whether our x will indeed be 2, we have to what? Say T3 divided by T2 equals 2. See if it will be equal to T2 divided by T1, right? So it will be 32. Let me just write it here. Né? It will be 32 divided by 10, which is equals to, let's see,
3,2.
3,2. Then can you check what 10 divided by 2 will give us?
5.
5. It's giving us 5. No, that's not correct. Okay, wait. We said this one it's negative 9 over 8. Negative 9 over 8. 2 all into negative 9 all over 8 plus 6. 16 all into negative 9 all over 8. Oh my goodness.
Skipper, love. Right. I'm right. Ngisafunda nje. Ngiseklasini bedabona. Ngizwe.
Okay, excuse me. I'm back. Sorry. Wait, let me cross check something now. Mhm. Why? We did something wrong over here.
Ngize something wrong.
Yeah, let me just do this, man. Wait. Because none of these two solutions is giving me a geometric sequence, and one of them should give me a geometric sequence. So let me just quickly try and do it, né? And see what we did wrong. 2x plus 6 divided by x equals to 16x divided by 2x plus 6. 16x squared. Okay, wait, let me just. Oh yeah. This is where we there. Yeah, this is where we went wrong. Remember, we said we were cross multiplying. Over here, we said this part we did it correctly, right? Because we said 16x multiplied by x. Over here, we're supposed to also put brackets in here and not just multiply the 6 in. Do you guys see where we went wrong? We kept this 2x as an individual thing. Yeah, that's where we went wrong. So let me. But the nicer thing is that if you are wrong from the get-go, it's not even gonna make sense once you're at the end. Plus 6 2x plus 6. So we have 16x equals to, when you multiply this, it is going to give you 4x squared, right? I'm just going to rush through this, but
Plus
just look.
24x.
Okay, it gave you 24x. Did you
Yes.
work this whole thing out?
Yes, I worked from the head. 2 times 6 is 12. 6 times 2 is
Okay,
12. So it's 24x. So it will be 4x
24x
squared. 4x squared. 2x times 2x. 4x squared plus 24x plus 36.
plus 36. Okay, this is what you get from this side, right? Now we want to, because this is squared, we want to make this a quadratic expression. We have to transpose this to this side, right? So we have 16x squared minus 4x squared minus 24x minus 36x, all being equals to 0, right? So when you say 16 minus 4x squared, you're going to get 12x squared minus 24x minus 36x equals to 0, right? Guys, I don't know what the hell is wrong with this. It keeps like taking
Take
me
the
out and
take 12 as the highest common fact.
yeah, you can divide everything over here by 12, 12, 12, and 12, because 12 is a common factor amongst all of these, are all multiples of 12, right? So you have
X
x
squared
squared minus 2x
minus 3.
minus 3, all being equals to 0, right? Now, from this point, it is easier now to work with. You can just say x equals to negative b plus minus root b squared minus 4ac, all divided by 2a, right? So our x will be equals to, what is our b? Negative 2. Negative 2 plus minus root negative 2 squared minus 4. What is our a? 1. What is our c? Minus 3, all divided by 2, all into, what is our a? 1. So you have x equals to 2 plus minus root. If you work this before, if you work this out, you'll have negative 2 squared minus 4 into 1, all into negative 3, which is giving you 16 divided by 2, which is going to be so nice to work with because you have a 2 plus minus
4.
4. Root 16 is 4. So 4 divided by 2. So when you take this, punch it all into your calculator. For the first x, because you're going to have two values of x. You're going to have x equals 2 or x equals 2, right? So now for the first value of x, let's just say 2 plus root 16 divided by 2, which is giving me 3. And then for the second one, where we're using 2 minus root 16, it's giving me negative 1, right? Negative 1. Now, as I was saying, we have to check which value of x do we have to use in this. It is that one. Yeah. So here's the question. We have to check in this expression over here, which value of x should we use? You can't just leave it like this, because if you leave it like this, then you're not telling them the exact answer for x, right? So let's substitute our x into this, because we have x. Then for the second one, we have 2x plus 6. Then for the third one, we have 16x, right? When we substitute in our 3, we're going to have 3, 2 all into 3 plus 6, 16 into 3. This will give me 3, 6 plus 6, that's 12, right? Okay. And then 16 times 3, which is going to give me 48. So now how we check if X is our solution? Remember, this is a geometric sequence. And we said T3 divided by T2 should be equals to T2 divided by T1, right? So now this is our T1, T2, T3 in this example. So we're going to have 48 divided by 12. And if you say 48 divided by 12, it should give you
3.
4.
Oh, 4.
4. And if you have 12 divided by 3, it is also going to give you 12. Cut the game.
4.
4. So can you confirm that this indeed will be our X will be there? You just say therefore X will be equals to 3 because 3 does make our expression, this expression that we were given initially, to be what? A geometric sequence. Do you guys get this?
Yes.
Okay. Love that. Um okay, good. I think we have a good question now. Oh, damn it, damn it. This was number. Okay. So we have the saying, we have a lot of time. Yeah, we're gonna finish this. They say the second term of a geometric sequence, geometric.
Hello,
Sequence.
where are the questions?
I'm just writing them down. Just rewrite
Oh,
it down.
okay.
Ne?
Okay, I
Yeah,
understand.
yeah. The second term of the geometric sequence is 5 over 1 to 8. And the ninth is 5. So they're telling us that in a geometric sequence, remember geometry, Tn, Ar, n minus 1. This is the formula that a geometric sequence is supposed to take, right? So they're telling us that the second term of a geometric sequence, which is n equals to 2, what will our Tn be? They're telling us that our Tn will be 5 divided by 128. And the ninth term, which means that n equals to 9, Tn will be what? Equals to 5. Right? They're telling us that determine the common ratio. Yeah. So we're given that the second term, again, it's what? 5 divided by 128. The ninth term is 5. Then from all this information that they've given us, they're telling us that we should deduce what our R will be. Our R being the common ratio, right? So for the first one, since well we had Tn equals to A, we're going to use simultaneous equations again, right? So let's just check how it will work out. So if Tn equals to Ar n minus 1, okay? They're saying that for the second term, the value is 5 divided by 128. So we know that this 5 divided by 128 will come here, right? We don't know what our A is because A is the first term of the sequence. We don't know. They just gave us the second term, right? A multiplied by R. What position does this 5 divided by 128 occupy? It's the second position, right? So we're going to have 2 minus 1. So we have 5 divided by 128 equals to A multiplied by R. 2 minus 1, it's just 1. right? So which means we have 5 divided by 128 equals to AR. This is the first equation that we're going to have, right? Now, for the second equation, we're going to say again Tn equals to AR n to the power n minus 1, right? For the second equation, we're going to say they gave us that the ninth position, it's occupied by a value 5. So we have 5 equals to A. We don't know what our first term is. R raised to the power. What is our n? Yeah, our position is 9. They gave us that. 9 minus 1. So we have 5 equals to AR. What is the difference? It'll just be an 8. Now, remember, we're trying to find the ratio, but we cannot find the ratio if we don't have A. So we have to solve for A, simultaneously also solve for R. So we're going to solve for two things here. In a way, we're going to solve for A and R, right? So now over here, we can make, because this R over here, it will be way too complicated to work with because the R, it's raised to the power 8. Unlike here, everything is raised to the power 1. So we can make our A the subject of the formula here, right? How can we do that? By dividing both sides by R. If we divide by R and we also divide by R over here, these two will cancel one another. We'll be left with A being equals to 5 divided by 128 R. So this is what our A is. Remember, we have our first equation over here. This was our second equation. This will be our third equation. What we can now do, take the third equation, substitute it where 3 into 2. Substitute the third equation into the second one so that we can work through it, right? So we will have 5 equals to, so now where you see A, you just replace A with this, right? So we have, what is our A? 5 divided by 128 R multiplied by R to the power 8, right? Now, remember this, it's just R raised to the power 8. It's divided by 1. So if you want to treat it as a fraction, you can just realize that it's divided by 1. You get it, ne? So we'll have 5 equals to, if you multiply these two together, right? If you multiply them together, you'll have 5 multiplied by R to the power 8, all divided by 128 R. Are you guys with me until this point? Like, you get what's happening until this point?
Yes.
Okay, great. Okay, fine. Now, as we can see over here, we have R raised to the power 8. Over here, we have R raised to the power 1. Remember, um laws of exponents, right? If we have R raised to the power 5 divided by R raised to the power 4, this is just the same thing as what? This is just the same thing as R raised to the power 5 minus 4, right? If you're trying to bring this, if you're trying to bring this to the denominator, this is the effect that it will have on the numerator, right? Similarly, if you have R squared divided by R, you will now have what? You will now have 2 minus 1. So which means this one, it will disappear because you're only going to have to remain with 1, right? So this 2, it will disappear. What I meant was if you have divided by R, this 2 will disappear because it will cancel out with this R over here, right? You guys get this? I mean, it's just like x squared divided by x. If you have an x squared divided by x, this one will cancel this one. So you'll only now be left with 1x, right? Because this is just the same thing as this divided by x. So this one will cancel this one, and now you're only left with 1. Right? Right?
Yes.
Okay. So now if we're here and we have an R, we have 5 equals to 5 multiplied by R raised to the power 8 divided by 128 multiplied by R. This one will be cancelled, and this one will also be cancelled because they subtracted 1 from this one, and you have a 7 over here. So now you have 5 equals to 5 multiplied by R to the power 7, all divided by what? All divided by 128. Right. So now, because we're trying to figure out what this R raised to the power 7 is, you can just make this a fraction as well so that you're able to cross multiply. And then when you cross multiply, reason why you're cross multiplying is so that you can have this R raised to the power 7 by itself so that you can actually solve for it. Ne? So when you cross multiply, you'll have 5 multiplied by R raised to the power 7, 7 equals to 5 all into 128, right? Let's work this out. 5 multiplied by R raised to the power 7 equals to, let's just say 5 times 128. It's 640. So now we can, because we're trying to make this R raised to the power 7 the subject of the formula, eventually potentially solve it, we have to now get rid of this multiplication. So we divide both sides by 5, divide this by 5. This and this will cancel. Now you're just left with R raised to the power 7 being equals to 128. But again, you're not done because we're not looking for R raised to the power 7. We're looking for R. So what you can do, you can add the square root, but not just the square root, with a 7 over here, so that this 7 can cancel this 7 over here. That's the effect that it's going to have. Then this one, it will also, because what you do this side, you have to do this side. Then this one will cancel this. Um, uh,
2.
sorry, it's 2.
Yes.
Okay, then our R will be 2. So now you have your R, which is what you were looking for. But just to complete the question, you can just take this R. Remember, they just told us to look for the common ratio. We got the ratio. You're done. But for the sake of the question, let's just take this R, substitute it back into A, right? So because so that we can have our A as well. Our A being our first term. So we'll have A equals to 5 divided by 128 multiplied by, what is the R? 2. A equals 2. Can somebody compute this for me?
Five over 256.
5 over 256. So now you're done with this question. You found your common ratio. And how did you do it? You did it by solving through simultaneously solving A and R. We all get this, ne?
Yes.
Yes.
Okay, beautiful. So as I said, the next time we meet, we will be doing exam papers based on this and functions and inverse functions, because last week we did inverse functions, right? Okay, fine. So now the last part of geometric patterns. We have the sum of an arithmetic sequence. Right? We have the sum of an arithmetic sequence. So remember, on an arithmetic sequence, we'd have like a whole sequence given to us, right? Whereby we have, let's say, 9, comma 11, comma 13, da, 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 da. right? And we said, let's just say it ends at 97. And then we said what an arithmetic sequence has is what? It's a common difference. Because I mean, moving from 9 to 11, 9, 10, 11, that's 2. Moving from 11 to 13, that's 2. So you see, our D would be 2, right? But if we say, let's say you try to find the sum of the entire sequence. Let's say you have it as 9, 11, 13, 15, 17, 19, 21, 23, 25, and eventually 27. If you have it like this and you're trying to find the sum, they tell you find the sum of this entire sequence. I mean, I know people that would go 9 plus 11 plus 13 plus 15. But because, bruh, it's a test, you're wasting time. They then formulated a formula that can help you just calculate the whole sum of the sequence without having to go one plus, right? I mean, we're eventually gonna get to the same answer. But what happens if they like gives you something so large, like from 9 until 900 and what? How you see? It's not practical, right? So the formula of the sum, it would go Sn equals to n divided by 2 2a plus n minus 1 multiplied by d, right? So this n in this particular thing, it stands for how many numbers we have in the sequence, right? And the a would be the first term again. This n would be the position, and then the d would be the common difference, right? Or you could easily just use this one. I don't think people use it a lot, but it's also applicable as well. So this is if you know the last term of the sequence, right? You're going to say a plus l. This would be the first term. This is the last term, right? So yeah, and this n would be again the number of terms you have in that sequence. So these are the two formulas that you can use to calculate for the sum. All right. Let me look for a question. Okay. Then we're gonna be done. Then yeah. And next week when we meet. Okay, guys. Those that attend every day, ne, what topic are you guys currently doing in class right now? Before I even wrap this up. Kumalo, what topic are you guys currently doing in class? Onyelits. Have Mutwaran. Oh, damn it. Okay, so let's say we have an 8, an 11, a 14, or going to 320, right? So, okay, right. Or maybe Halim Good, you guys, can you hear me? That would be the funniest thing ever. Oh, okay. Ke a re ke gagametse mo ntse ke le sum. Okay, great. And they're telling us calculate the sum of this sequence over here, right? Okay, so as we sorry.
Ke re mo tshware Darren ka pele moo.
Darren, what were you? Okay, I wanted to ask what topic are you
Angizwa.
guys what topic are you guys currently doing in class now for maths?
We are currently on inverse functions.
Oh, okay, perfect. Okay, good. Thanks, Ne. So sharp. Let's say they
So
tell
guys,
us to. Yeah, you were saying?
can I ask a question? Did you all start with number patterns or you started with inverse functions then number patterns?
We did algebra, then we did functions, then we did inverse functions, and now we're currently doing number patterns. But I'm saying next week we're going to do questions based on functions, inverse functions, and number patterns.
Okay.
Yeah. But you can like watch videos for inverse functions and functions on on YouTube. I'll just make sure I send the link to you after class, innit?
Okay.
Sure. So okay, they're telling us look for the sum of this, right? Remember we said the formula would just be Sn equals to n divided by 2, 2a multiplied by no, I'm lying, plus n minus 1 all multiplied by d, right? So we're given this, we said this n over here, it's the number of terms in the entire sequence. So if we say from 8 until 320, how many are they exactly in this? But in this question, we don't know what the n is because they didn't give us the whole entire, it's missing. They gave us like a few terms and the last term. But what we can do is we can find out what position this 320 is at. Then we can conclude that that n that we get will be the number of terms in the sequence. You guys understand that, nah? Do you guys get that? Like what I mean?
Yes.
Yeah.
Yes, you understand.
Okay. So we have to get the nth position of 320. So we're going to say Tn equals to a plus n minus 1 all multiplied by d, right? We didn't get what our difference was. What is our difference? 3, ne? Yeah, it would be plus 3 because 8, 9, 10, 11. Yeah, plus 3 plus 3, right? So our D currently it's 3. Our A equals to 8. A, it's our first term, 8. Our Tn will be 320 because we're trying to find the position of 320. And remember, our position is N. So, okay, we're going to go 320 equals to a plus n minus 1. What is our d? Our d is 3. So we'll have 320 equals to 8 plus, let's now multiply in. So we'll have 3n minus 3, right? So we'll have 320 equals to 8 minus 3. It will be 5 plus 3n. Now we're trying to solve for this 3 for n, right? So we can just take this 5, transpose it to the other side. So we'll have 320 minus 5 equals to 3n, right? So we have 315 equals to 3n, right? So if we divide both sides by 3, what will we have? Our n as
63.
53.
63.
No, then
It's
Yeah.
105.
Yes. Oh, I made a mistake. I see.
okay.
Oh,
Our
it's
n is
105.
okay. Our n is 105. Thank you. So you see the position of the 320th term. No, I'm lying. The position of 320, it's 109. So this 320, it's situated, it's found at 109. 105, sorry. 105. Okay, fine. So which means, therefore, because it's the last term, it now means we have 105 terms in this sequence, right? So now we can compute our sum because that's what we wanted to do initially. So now we're going to go, let me just say 4. Now we're going to go and say, okay, our Sn, which is the sum, will be equals to, what is our, okay, you can see the formula over here, right? I don't need to rewrite it. What is our n? 105 divided by 2, all divided by 2, all into, what is our first term of the sequence? It's 8, right? Multiplied by 8 plus, what is our n? Again, 105 minus 1 multiplied. What is the common difference that we have? 3. Sn equals 2. Can you just do this for me, please? Into the calculator. Guys, ya pala go le go kalo. Mathata matsapedi a tsaya kae?
At 17,220.
17,220. So this will be the sum of this sequence over here. So do you guys get that too?
Yes.
Okay, great. We're done for today's lesson. Remember, I said the nicest thing about patterns is that they're very short and quick and straight to the point. So next week when we meet, we're doing yeah, we're strictly doing questions because now you guys understand the concepts, right? Doing questions, the patterns and functions and inverse functions. So yeah, may we all join on time next week because it'll be very important, and I think it'll be better off if you attend like early. Ne?
Yes,
Yes.
sorry
Okay.
for any inconvenience.
It's okay, no problem. I wanted to ask guys now. Okay, fine, we're done with today's class. So I wanted to ask you, what do you think it is that I could do that could like make the classes even better? Like that could make like all of this what we're trying to do, me trying to help you, like make it even more better. What do you need that I'm currently not doing? Because currently all we're doing is like we're learning and then we come back, we do questions. We're learning, coming back, doing questions. So what different thing would you prefer I do?
Ma'am,
Yes.
you are very good at explaining, but I'm just asking that when you are doing questions, but we don't do past papers, isn't it the same as learning but not practicing?
Yeah, that's why I'm saying next week's class it's just reserved for past papers.
So will we be doing questions then you correct us?
Yes.
Yes, that's better. That's all I wanted to know.
Yeah, that's what we were supposed to do it today, but I thought it would be better if we just and do this and then next week when we do them we just combine patterns, inverse and functions as well.
So since the class is dismissed, can I ask all of you Tswanas, because I heard you speaking Tswana a little bit.
Yeah, we're all
No.
Tswana. No, we're not, sorry. Sanaliswa Siwe is not Tswana.
Okay, I get
Okay,
I'm
it.
Zulu, by the way.
you're Zulu.
Yes.
Yeah,
He's also
ngumZulu.
Zulu.
Yeah.
Okay. Zulu. So it's exam question papers, right? Okay. That's good. So another thing, what would you guys prefer? What more?
Nna ke batla go itse ka like format, like obviously like like what bontsha how we get to the answers, and
Mm.
sometimes going like maybe we can answer only like out of two. So like the format, by the time I read the questions, like you should also show us who no, this is how you actually gonna answer it, so that the rest are quality paragraph. Yeah.
Oh, okay. Okay. So how you're supposed to approach it in the exam.
Otherwise, go quality paragraphs to tsotlhe.
Oh, okay. 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 That's good. Okay. Okay. I get it. Another thing.
Oh, can you also please show us the mark allocation?
The multiplication. Okay.
Yeah.
I think it will fall under formats because yeah, they're one and the same thing. So we are both agreeing that next week we'll be doing exam past papers based on this, right? And then Kusho trigonometry will start it the week after that one.
Oh,
Okay.
Yeah,
Say,
but trigonometry is very easy. I don't think people should struggle with trigonometry because grade 12 trigonometry just needs grade 11 application
Wow.
and a little bit addition.
Darren, even if you don't think it's difficult, but we're going to thoroughly do it. Now we're going to treat everything as if it's difficult so that when you go into an exam, you know that most of the things you know them for sure. Nah.
Yeah, yeah, it's very crucial to treat everything like it's difficult because this is maths. You never know the
Exactly.
exam.
Can
You
shock
don't. You
you.
never know the examiners.
Exactly. Can do the most ridiculous thing ever. And so everything you have to treat it as if it's important. So yeah, next week, patterns and functions. See you there. Be there.
I
Sharp, sharp.